Good morning, and as always,
Slow is smooth and smooth is fast.
so what we're going to look at here is a velocity versus time graph. So before we looked at position, now we're going to look at how velocity looks. Pretty much the same subject. I'm going to be walking backwards and then forwards, but a very different graph. So you'll notice that there's some noise in there, but as I'm standing still, I should not have velocity. But you'll notice something different as soon as I move.
Okay, so we get this peak. Now we have an increased velocity, and Mr. Schmidt is stepping away from the motion sensor. But what we want to highlight is here he stepped away and he stopped moving. So although his velocity increases as he's moving backwards, the moment he stopped moving, it's going to drop back down to zero.
As I walk backwards, my velocity ends up ending at zero, but I still get that same decrease and then coming back to zero because I'm walking back. So I have a negative velocity. Even though I went from the initial position back and then forward, I have a negative velocity.
So what we can do is just think of those lines. When you have a horizontal line for velocity versus time, the velocity is zero. When you have a line with a positive slope, you know that the velocity is increasing, which tells us actually that the distance is increasing. When the velocity has a negative slope, right, we know the velocity is decreasing. That doesn't mean the distance is decreasing, right? When the velocity is negative with a negative slope, then we know that the distance is decreasing.
And then we can see one more step forward and that same negative velocity, but a decrease.